Hello 8th graders, here another little demonstration on air pressure dealing with our weather unit. And we've got a vacuum bell jar here, a vacuum that's going to be created inside here. Here's our little on-off valve for it. The vacuum pump is down here, and we'll be using this several times. And then we got several objects we're going to try. So I want you to think about what's going to happen when we take our first one, will be this balloon, and put it inside our bell jar and vacuum the air out. So when we look at this, number one, there is a little rubber gasket essentially that's going to seal it in there. So that's what allows that vacuum to stay. So make some predictions as to what you think is going to happen to these different objects, and there are a number of them, and I'll show you quickly with each of them. But all right, so here we go with this first one, and flipping the switch. What do you think is going to happen? Right away, I'm noticing that it's definitely growing, getting larger. So now you got to think about the pressure inside here. I'm vacuuming the air out on the inside of this container. It's being suctioned out. So it's not a vacuum cleaner, it's a vacuum pump. It's suctioning the air out, okay? All right? And so now if I shut this off, I haven't switched the valve yet, but if I shut this off, what do you think is going to happen? Is it going to pop? Is it going to explode or implode or what? Is that what you predicted? All right, so we can see there's a difference of pressure. All that pressure, we've got very little pressure on the inside of that bell jar. And so the air that was on the inside of this balloon was able to expand, had less pressure. So it's kind of like in the hallways right now at school, there's no pressure, right? So if there was a single person, they got lots and lots of room so they can expand as much as they want. So it's the same idea here. Air or weather is all about a difference in air pressure. So that's the first one. We've tried that one. Now I want you to make a prediction with this flat balloon. This is basically the opposite. Now it has been tied off. There's a knot there. Okay, we'll put that one inside. We'll tap it off, or top it off. And here we go with that one. Make a prediction. What do you think is going to happen? That was basically a flat balloon tied off on a knot. What do you think? I see zero change. Is that what you predicted? Alright. So that one, again, you can see the vacuum pressure there, the vacuum that's created. Kind of neat little effect, but this one had nothing. There was nothing that happened because there was basically no air on the inside of this flat balloon. It was the dead balloon. How about this one? We got a situation with a test tube. We've put around the lip or the mouth of the test tube. We've got a balloon there. There is a tiny amount of matter on the inside of that. Okay, and let's see what happens here. Make your prediction. Well, right away it's getting larger. Again, think about that air pressure. Again, the question is, the difference in air pressure is what makes? The answer is weather. Alright, so you're seeing that happen there. Okay. Alright. So was that exactly what you thought? How about another one? Now this one, partially filled. Okay. Did we do that one already? No, we haven't. It's the same color as the white one. Try this one. Is that what you expected? And again, think about pressure. Where is the low pressure at right now? When you think about a weather map where we have lows and highs, and big capital L's and the capital H's, where is the capital L in this weather system? Where's the capital H? Okay. All right. So we've seen that enough, I think. Okay, now let's go ahead. Let's try. We got two plastic bottles here. One without a cap and one with the cap on. And what do you think is going to happen with these two when we vacuum the air out? So make your predictions. And a little technical difficulties there. Now the one that's filled up, it's definitely moving right away. The other one, I didn't see any motion in it other than when the other bottle with the green cap moved it. That's about all I'm seeing out of the plastic bottle with the cap is definitely completely filled. I think that's about all we're going to get with that one. So you can see this didn't start full 100%. I guess it's pretty close, but anyway, this one didn't do anything. Does air pressure affect some things and not others? What do you think? We got a 200 volt, 2000 volt capacitor that's used in a microwave oven, and I want to make sure I got the right number on there. I probably should have just looked at the label on here, but so anyway, what do you think is going to happen to this? Pretty solid? Let's give it a whirl. Okay. Is it growing? Is it getting bigger? Nah, not doing anything. Physically, the whole thing shook a little bit there, but no, nothing happened with that. Okay. What do you think is going to happen? We got a foam ball, you know, a little, not real bouncy. Got a little bouncy ball for playing around. What do you think is going to happen here? It's a foam. Okay, make your prediction. And not seeing anything. I thought maybe there'd be some air in there that would have an action. Nope. So apparently the foam that's in there really doesn't have a whole lot of air on the inside, because if there was air on the inside of that ball, it would have had plenty of room to open up and expand, and just like it did with the balloons. But apparently that foam ball is a little different situation. I didn't really see any change in size whatsoever. Okay, how about the ping pong ball? We know there's got to be air inside this. Now it's definitely, you know, they're pretty solid, but what do you think is going to happen with this? Let's see. I'm not seeing any change. I didn't see any change there. Obviously it's affected by that rush of air going back inside, so that difference in air pressure, what weather's all about, didn't really have enough impact on this, because that ping pong ball is fairly solid based on its shape, that spherical shape. Okay, now one more demonstration for you. This one's kind of fun. You have a little shaving cream, and so we're going to go ahead and put some shaving cream in here. Oh, we know there's some air in that, but not as much as we were hoping. It's kind of a dead can. The aerosol's dead in it, but let's see if it has anything as far as its action. So this one may not be as effective as we were hoping. Safe. All right, so here we go. You can have a good laugh there. So we do have some shaving cream in there. And we'll put our lid on, and here we go. Make your prediction. So even though it didn't have a lot of aerosol in it, or propellant, it still is responding. So what gas was on the inside of that shaving cream is definitely filling it up. It's definitely filling it up. And you can see it pretty much kind of liquefied some of it and splattered the inside of that bell jar. So, golly. All right, so anyway, weather is all about a difference in air pressure. All right.